Okay, picking up where we left off, like I said, we are in our Cartesian plane. The information on the screen is what you need in order to be able to solve a question like this, right? So yeah, take note of this. We have sine equal to a certain ratio. So we're going to go look at this over here. Why am I looking at that? Because I've got sine in my question. Okay, so I'm looking at that. And sine is y over r. Okay, so if I have sine of theta equals 4 over 5, okay, then this tells me that, let's put this in some other color, that 4 is my y value, and this 5 over here is my r value. Okay, so okay, maybe we should discuss first which quadrants we are in. Okay, so let's go look at two things. In order to decide which quadrant you are in, there are two things you need to consider. Okay, the two things are this: you need to look at this red block that I've got over here. We are dealing with sine, and we can see that sine is this is a positive number, so we're going to look for sine in the positive quadrant. Okay, so let's draw a Cartesian plane for ourselves, and we remember cost, C-A-S-T, cost. Some teachers teach it as all stations to Cape Town. Fine, whatever you wanna, however you choose to remember that, that's perfectly fine. I remember cost, C-A-S-T. Remember that the C must start in your fourth quadrant. Okay, so what I said was we are dealing with sine, and sine is a positive number. Okay, because sine is a positive number, we go to the quadrants where sine is positive. In which quadrant is sine positive? Sine is positive in this quadrant as well as that quadrant. Okay, A is for all, S is for sine. So sine is positive in the all and the sine quadrant. The next thing we do is we look at our restriction. Now this is our restriction. Sometimes our restriction looks a bit different. Okay, so sometimes it will be like between 0 and 90 degrees, between 0 and 180 degrees, or between 90 and 270. And when your restriction is like that, then you consider that this is 0, this is 90 over here, this is 180, this is 270, and again this is 360. So if, for example, I say from 0 to 90, then I would be there. If I say from 0 to 180, then I would be in those two quadrants. If I say 180 to 360, then I would be in these two quadrants. Okay, so if my restriction were like that, that's what I would look at. So this one is slightly different. Okay, it is tan of theta is smaller than 0. Tan of theta is smaller than 0. That means it's negative. Anything smaller than 0 is negative. So now I ask, where is tan a negative value? So I will say tan is negative in this quadrant as well as in that quadrant. So those two quadrants has tan negative. So that's what this restriction means. Tan is smaller than, so it's a negative. Which quadrant is tan negative? Okay, so we have highlighted the second quadrant with two ticks. The second quadrant meets both conditions. It meets this condition, it meets this condition, and because the second quadrant meets both conditions, we will have our diagram in our second quadrant. Great. So now let's go down here through our Cartesian plane, and we're going to draw a point in our second quadrant. And once you have that, you need three things. You need a x, you need a y, and you need a r. Where do we get the x, y, and r? We get it from this thing that's already nicely next to it over here. Our x value, okay, we don't have x. Our y value is 4, so let's go put the 4 there. Our r value is 5, and now we need to find x. Okay, the way we're going to find x is with, okay, so along with these, there is another formula that we need to remember. The other one is r squared equals x squared plus y squared, right? So that is our Pythagoras. That's also our circle formula. Okay, so don't worry too much about the circle formula. That's beyond our content for now. That's Pythagoras, right? So these formulas over here as well as this one is the building blocks for this question, right? So now you need to find x. So we are going to manipulate this formula so that we can get x. So I'm going to write it like this. I'm going to say that x is equal to, and I'm gonna say plus minus the square root, and I'm gonna put my r value first. My r value is 5. I'm gonna square that, 5 squared, and then I'm gonna say minus, and I'm gonna put my y value. My y value is 4 squared. Okay, so what did I do? I did skip a bit of steps. Maybe we should discuss those first. Okay, so I will continue with this, but what did I do? I substituted my r value. My r value was 5, so I said 5 squared equals x squared plus our y value is 4 squared. Okay, and then I wanted x alone, so I took this positive 4 over. We know that we are subtracting that on both sides. Okay, so then it would end up being, let me write on this side, it would end up being x squared on your right hand side equals, here on the right hand side, I'm just choosing to write it on the left now because we like our variable on our left, equals the 5 squared. We wanted to get rid of the positive 4, so we subtracted 4 squared on both sides. And then in order to get rid of the square, we have to square root both sides. Okay, and now notice I put this plus minus thing over there, and that means both plus and minus are going to be options. Okay, so let me get rid of this, but this is how we ended up with that part on top over there. Okay, right. So the reason that we have plus and minus is because of the quadrant which we find ourselves in. Okay, so we find ourselves in the second quadrant, and within our second quadrant we know, so the second quadrant, your x's are on your left hand side, and on your left hand side x is negative values. So after you do all of this, after you simplify this, you will have plus and minus all of this in the calculator, gives us a 3, but we have to accept the negative 3. So we're going to take minus 3, we're going to throw away plus 3. What does this mean? This means that plus 3 is an option as well as minus 3 is an option. We're picking minus 3 because we are on our left hand side of our Cartesian plane. So this is going to be a minus 3. Okay, so what did we do? We used these ratios, right, and our information from our question to help us find x, y, and r. That told us what y was, it told us what r was. We used Pythagoras in order to find what x was, well, what x is. Now that we have x, y, and r, we can go back to our question and we can solve this. Okay, so how are we going to solve it? Again, these ratios, right? So we know tan is equal to y over x. Where's y? Y is our 4, so that's going to be 4 over x. X was our negative 3. Right, so that's that answer over there, 4 divided by negative 3. Okay, and let's do the second part as well. So this over here, I'm going to write it over here because I'm writing all over the place. Okay, so the 2, I'm writing the 2. The cos, so I'm going to open a bracket and I'm going to close a bracket, and this is cos something squared minus 1. Okay, so now let's go look at our ratios over here, and cos is x over r. So we go back to our diagram. X is the minus 3, so this is going to be the x minus 3 over r. R is our 5. All of this we can go put into our calculator. So 2, 3 squared is 9, and 5 squared is 25, and we have to subtract 1. So 9 is 18 divided by 25 minus the 1. That goes into the calculator, and the calculator says negative 7 over 25. Alright, so that's how we deal with this question. Let's just walk through what we've done because it was a bit much, right? So you need, in order to deal with this question, you need these ratios. Okay, so either you remember these ratios or you know where to find these ratios. They came from that circle, that triangle in your first quadrant and Sokotoa. Okay, so the first thing that you do when you solve this question is, 1, you determine which quadrant you are in. Once you determine which quadrant you are in, you need to find x, y, and r. You did that with these ratios. Once you have x, y, and r, then you can go plug them in again into those ratios, into the question that you have, and then you just simplify. Okay, Good luck.